Okay, so here we're using the sandwiching argument. So if we just find the area of the rectangles here, you can see each of these rectangles is has a width of 1, and the height of the first one, so if I just sum them, the height of the first one here will be, we're looking at that inverse tan x function, so that'll be inverse tan of 1. Whoops, inverse tan of 1. Second one would be inverse tan of 2. So that's that height, all the way up to this height, which is inverse tan of n. Inverse tan of n. That's what that is. Now, if you think about that sum of those n rectangles, it is between, so you can see if I found the area above all these, that would be bigger. So that would be looking at the actual integral of inverse tan of x between 1 and n plus 1. And if I go below, so this part, you can see that is this function. So I'd be integrating this function, inverse tan of x minus 1, with respect to x, between 1 and n plus 1 as well. Oops, I didn't put my with respect to x there. So that's handy for later. Now, if we go to B, where we want to differentiate x inverse tan of x, I'll just do it down here. So we want to differentiate x inverse tan of x. So if we differentiate the first, we get 1 times the second, so inverse tan x, so it's product rule, plus derivative of tan x is 1 on 1 plus x squared, inverse tan x, sorry, using your formula booklet, and we're timesing by the first, which is x. So we get that. Now, another way of writing that is to say, well, when we integrate that, we get back to that. So when we integrate inverse tan x dx and this one with respect to x, we get back to x inverse tan of x plus c, because we've got indefinite integral. And say we just wanted this one, then we'll put this one on the other side and we'll integrate at the same time. So we'll say that that is equal to, well, we already know we've got that bit, so we've got x inverse tan of x. I've also got minus this integral here. So let me just integrate that separately. So I need a 2x on top, because then that will be the derivative of the bottom. So I'm going to put a half out the front of a 2x. So it's the same integral. And now you can see it's just a half log. And this is positive of the bottom, and the bottom's positive, so I don't need absolute values. So here I'm minusing half log 1 plus x squared. And of course, I'm going to put all the constants together. So I get plus c. Alright, so that's just rearranging that. So differentiate x inverse tan x, hence find a primitive of inverse tan x, right? We've done that. So now let's show this. Okay, so now I've shown you that. I'll get rid of this bit. So going just back to what we'd written above, this Sn, if I do integrate, and I'll use this here, if I integrate between 1 and n, I'll do that first. So, sorry, 1 and n plus 1, then I'm going to do this between 1 and n plus 1 and get rid of that plus c there. So when we do that, what do we get? Let's have a look. So I'll do it up here. So if I sub n plus 1 in, I get n plus 1 inverse tan of n plus 1. Excuse me. Minus a half log n squared plus 2n. So I'm squaring straight away my n plus 1 and then adding 1. So if I'm squaring n plus 1, I get n squared plus 2n plus 1, and I'm adding that 1, so it's plus 2. Alright, and then minus, now sub in 1, so I get 1 inverse tan of 1, which we know is pi on 4. And then minus minus is a plus, half log of 1 plus 1 squared, which is 2. So if I put these two logs together, what am I going to have? I'm going to write it right in here. I'm going to have n plus 1 inverse tan of n plus 1 minus, now I'm doing minus a half, so if I change that to minus a half, that will be, I'll put a negative here, so that's actually, that 2 is going to become a half. So when I'm subtracting, or we could just leave it as positive. It's very hard for you to understand, isn't it? Here, so I'm not explaining myself very well. So minus half, you've got log of this. So if you wanted minus a half outside, it would be minus log 2. There we go. So I've factorized by minus half, just those log bits. And we know when it's a minus, we use divide for the logs. So we're going to have half log, and in here we're going to have n squared on 2, 2n on 2, which is just n, 2 on 2, which is just 1. And we've also got that minus pi on 4, haven't we? Don't forget that one. All right, so that's just subbing in using this function here. So I'm going to now get rid of that since we have no room. And now I'm going to sub in, so now I want the integral of, so over here, have I got blue? Yeah, over this one. I want the integral of inverse tan of x minus 1. So I'm going to change all these to x minus 1. That's fine because the derivative, that's just 1. So now, I'll change this at the same time. That's going to become x minus 1, inverse tan of x minus 1. And here we're going to get x minus 1 squared. So I'm going to have to rub that out, aren't I? So here, this bit will be 1 plus, so x minus 1. So x squared minus 2x plus 1. And I'm going between 1 and n plus 1 again. So really this is x squared minus 2x plus 2 for that bit there. Alright, so now we sub in n first and then 1. N plus 1 and then 1. So when I sub n plus 1 in, n plus 1 minus 1 is n. So I'm going to write it over here, but it really just goes here. So n inverse tan of n plus 1 minus 1, so that's n minus a half log. Alright, so here we've got, if we just sub in out our n plus 1, we've got n plus 1 squared. So n squared, 2n and 1, and then minus n squared, 2n and 1. Minus 2n's, minus 2's, plus 2. Alright, so that was just subbing it into here. I don't know why. Anyway, minus, now let's sub in 1. So I'm going to have 1 inverse tan of 1 minus 1 there, if I sub in 1, which is inverse tan of 0, so it's just 0. So I'm going to forget that term. Then I got minus minus, which is plus half log, and subbing in 1 here I get 1 minus 2 plus 2, which is 1. That's also 0, so actually I can get rid of that. So here I'm going to have n inverse tan of n minus a half log of, what have we got? N squared, 2n minus 2n, and 1, just 1. There we go. Don't even need, just need those brackets. Alright, so that I would put up here. So Sn is between those two things. Now clearly to deduce this part here, the D, you can see that n is 1000. So if you sub 1000, n equals 1000 into the right hand side and the left hand side of that inequality, we should get this answer. Because the right and left hand side then are just numerical answers straight. There's no variables in them. So give it a go. Hopefully you get there.